So, very good evening, my dear students. How you all are doing? Hopefully, you're doing fabulously fine with your preparation as such. So, in today's session, I will be focusing on previous year questions from class 11 and class 12. Okay, so this is the first part of discussion as such. Okay, and in this part, I will be focusing on the high weightage concepts from class 11 firstly, like we have waves and oscillation. Okay, so I have picked out this waves and oscillation concept well in advance now, so that let me just move ahead and learn these questions comfortably. Okay, so without much ado, now let me just move on to the very important essential thing, that is regarding Unacademy Plus subscription. Okay, now since from the beginning I was mentioning to you regarding Unacademy Plus subscription, now it is the high time for each one of you dear students to go ahead and grab this opportunity at the earliest, because Unacademy Plus subscription is a must now, because hardly another 4 months are left for your Karnataka CET preparation. And in order to accelerate your preparation, I suggest you go ahead with Plus subscription now and now itself. Okay. So with reference to the today's discussion, dear students, so let me just talk about Plus plan. If you're planning for Plus subscription, suppose, then I suggest why you are planning, that you must be knowing, no? So hence I will say, like, you should notice that in Plus platform there are 20 plus top educators. Okay, including me, there are 20 plus top educators, and these 20 plus top educators are running successfully 10 plus batches right now. Okay, and there are 250 plus courses which have which are under progress, or which have been completed. Okay, and there are 2000 plus lessons which are present already this year. Okay, so it is one of the added advantage for you people to have a diversified material. That is most important thing. Do you agree? Okay, so and apart from this, I would say many more lessons are added day in and day out here. That is also a very important thing that we should remember. Okay, now let me just talk about why do we require this, the reason. Now the reason, I told you the backbone strength behind this Plus platform regarding educators, batches, courses, lessons, right? Now, let me just tell you what exactly or why exactly I'm telling this to go ahead and grab this Plus subscription. Firstly, let us try to learn benefits. What benefits you can gain? Now, we have firstly a premium content at a very much affordable price. Now this is the must, so I would say this is the must, so important, huh? Because you will always expect what, something premium for your price, and this price what you pay for Plus subscription is highly affordable. I'll come to that pricing a bit later. Okay, and the content, it is highly premium, world class content, we can say. Then we have structured live courses with dedicated live doubt clearing sessions. Now here, these are key focuses here: live doubt clearing sessions. Okay, and each of the courses are well structured. Okay, say for example, suppose I am planning to deal a class on a course on electrostatics, then it will be highly structured with reference to electrostatics topic as such. Then based on this, we will be conducting what? Doubt clearing session, day in and day out. For every course there will be a live doubt clarification session. Then we conduct quizzes. Quizzes are conducted at regular intervals along with the course itself. Then we have batches for complete preparation, dear students. Okay, not for one subject or two subjects. For complete preparation for Karnataka CET, a full preparation, you can go ahead and grab this. Okay, then we have a test series. Now, this test series has many modes and parts. Like, for example, we have DPPs here, daily practice papers. Then we have full length mock papers. Now, full length mock papers are actual KCET papers that you will be solving. And these things come with analysis here. With analysis. Okay. Now, hence, I can say single subscription, unlimited access. Because if you are getting all these things at a very much affordable price, what else you require? Okay, so obviously, this is the best thing I can say, and hence I'll say everything under single plus subscription, dear students. So please be attentive towards this. So I can say single plus subscription. If you just get, you will get everything. Okay. Now, apart from that, suppose you want to get a 10% discount or off on your subscription, use my code. Use the referral code of your teacher, that is UTTAMLIVE. That is the referral code. Fine. Now, let me just talk about pricing plan. Now, pricing plan, when it comes to, there are several plans. The first one is a basic plan. Now, this basic plan comes with 1 month duration. For 1 month, it will cost 1500 rupee per month. Okay, so now second plan is a 3 months plan, and this 3 months plan is costing to you 3750 rupees for 3 months. Okay, and over here you can avail a 0% EMI here. Okay, 0% EMI, that is 1250 rupees. Okay, then talking about third subscription plan, that is 6 months plan. Now the 6 months plan is costing to you 6000. Now previously it was costing about 11,000 odd including the taxes, but now it is almost like 6,000 for you. So look at the cost cut down that has been made in Unacademy Plus subscription plans. Okay, then here we have 1000 rupee per month, that is the 0% EMI that you can go ahead and avail for 6 months plan. Okay, then apart from that, I will say this is the recommended plan for PUC second year students. Okay, so this is for PUC second year students or class 12 students. Now this is the recommended plan for you all. Then we should talk about one more thing, that is a 12-month subscription plan. Now 12-month subscription plan, it used to cost around 13,000 rupees, okay, previously including taxes, but right now it has been cut down to 8,250 rupees for 12 months. Okay, so divide it by 12, then you can avail an EMI at 687 rupee a month. Okay, now this is actually again a 0% EMI. Okay, then we have 24-month plan. Now this 24-month plan would cost 12,000 rupee. Okay, which used to cost around 22,000 odd, including taxes. But now straight away a 10,000 deduction has been made in this. Imagine. Now, if you'd like to avail an EMI, just pay 500 rupee a month for 2 years. So that is 0% EMI that you can avail for 24 months. Okay, and let me remind you, these 12 months and 24 months plans are best suited for the students who are in PU1 or class 11. For them it is best suited, 12-month plan or 24-month plan. Okay, so this is what like I would like to say. Then suppose you want to get a 10% deduction or off on any of these subscriptions, go ahead and make use of my referral code, YouTube referral code, that is UTTAMLIVE. Okay, you can get 10% off from this. Imagine, right? Okay, so this is a gift from your teacher, I would rather say. So now let's begin our discussion for the day, dear students. Let us go ahead and start with our discussion. Now, question number one for today. Vijay Kumar, good evening. Okay, so now if you just take a look at this question. hmm, The amplitude and the time period in simple harmonic motion is 0.5 centimeter and zero point 0.4 second respectively. If the initial phase is pi by 2 radian, then equation of simple harmonic motion will be. Okay. Now over here, now we shall consider the general equation for simple harmonic motion as y is equal to a sine omega t plus phi, where omega is what? Omega is angular frequency or angular velocity, and phi is initial phase of that particular oscillation. Okay, and I'm considering it to be a sinusoidal oscillation. Okay, now after this, let me just write omega as 2 pi by t, because omega is angular velocity, right? Angular velocity can be defined as what? Ratio of 2 pi to time period. So this is how I can write it off. Okay. Then over here, why did I do this? Because they have given time period in the problem. So for that reason, I've converted omega in terms of time period. Okay. Now after this, now let me just go ahead and write back the equation as y is equal to 0.5 sine of 2 pi by 0.4, because time period is given as 0.4 for us, is it not? And initial phase is given as pi by 2 in the problem, and 0.5 is the amplitude which is given in the problem. So accordingly, I'm mentioning all these things. Now 2 by 0.4 is 20 by 4, which will be equal to what? 5, is it not? So hence I can write this as zero point 0.5 sine 5 by t plus pi by 2. Now this is the equation that I've obtained. But let's wait, friends, because if you just to take a look at the options are not given like this. None of the options are with plus pi by 2. Okay, so but there is one option with cos, right? So hence I'll make use of the allied angle relation. What is that? Sine of pi by 2 plus theta. Sine of pi by 2 plus theta is cos theta, is it not? So let us make of this allied angle here. So accordingly, I can write this as 0.5 cos phi pi t. Now theta is phi pi t here. So hence we have obtained the value as 0.5 cos phi pi t. Now this is the answer that we are looking for. I hope this is the equation, or this is the displacement equation which is asked in the problem. Okay. Now let us move on to next question. Question number 2. The equation of simple harmonic motion is y is equal to a sine of 2 pi nt into 2 pi nt plus alpha. Then its phase at time t is. And dear friends, this n is nothing but frequency here. Okay, so 2 pi into frequency is what? Omega, right? So hence it is as good as writing omega t plus phi. So comparing it with standard equation, sine of omega t plus phi, we can see that here the phase is obviously alpha here. So hence we'll mark option B as our right choice here. Okay. Now let me move on to third question now quickly. A particle in simple harmonic motion is described by the displacement function x of t is equal to a cos omega t plus theta. If the initial position of the particle is 1 centimeter and its initial velocity is pi centimeter per second, the angular frequency of the particle is pi radians per second. Then its amplitude is. So here they have given three conditions. One is position at t is equal to 0, position of the particle is 1 centimeter. That means x is equal to 1 centimeter at t is equal to 0. Okay. Secondly, its initial velocity at t is equal to 0, velocity is pi centimeter per second. Then angular frequency of the particle is given as pi radian per second. Now these are three things. Angular frequency means it is omega here, is it not? So hence let us go ahead and write down the solution. Now, I'll write the required equation in the form of standard form, that is a cos omega t plus theta. This is x is equal to a cos omega t plus theta here. Then accordingly, and v is equal to, I can write it as dx by dt, and dx by dt is nothing but derivative of x with respect to time. So hence we know that derivative of cos is minus sine. So hence I have written it as minus a sine omega t plus theta into derivative of omega t is what? Omega. So hence all in all we can write it as what? Minus a omega sine omega t plus theta. Now let me consider this as equation number 2 now. Okay. Then it is given that at t is equal to 0, x is equal to 1 centimeter, v is equal to pi, and omega is equal to pi. Now, these are the three things that I will substitute in first equation and second equation. Okay. Now, in first equation, I can substitute x equal to 1 centimeter, t is equal to 0. Okay. So, here if I put x is equal to t is equal to 0 in the first equation, if I put t is equal to 0, what we will get? We see that it becomes a cos theta, is it not? A cos theta is equal to 1 here because x is 1. So this implies cos theta is equal to, we'll get this as 1 by a, right? Similarly, in second equation, if I put t is equal to 0, at t is equal to 0, v is pi. That is what they are saying. So hence I can very easily write this as what? Minus of a into omega into sine theta, okay, equal to v. Now over here omega is pi and v is pi, we can cancel them off, is it not? So pi and pi cancel off, so thus I can very easily write sine theta is equal to minus 1 by a here. So sine theta is minus 1 by a. That is what we will get, that is what I have mentioned here. So putting these values in equations 1 and 2, we get sine theta equal to minus 1 by a and cos theta is equal to plus 1 by a. So this is small a here, I'll make correction, this is small a. Then now what we'll do, we'll square and add these two. So hence I'll write this as sine square theta plus cos square theta is equal to minus 1 by a whole square plus 1 by a whole square. So clearly we will obtain this as what? 2 by a square is equal to 1 because sine square theta plus cos square theta is 1. So therefore I'll get a square is equal to 2 or a is equal to root 2 centimeters. So this is the answer that we are looking for. I hope I'm clear on this part. Okay. Now let me move on to fourth question now. A particle executing simple harmonic motion along y-axis has its motion described by y is equal to a sine omega t plus b. The amplitude of the simple harmonic motion is. Now, remember this equation, even though it looks a bit different to me, but here plus b what we are mentioning, this is some inertial factor. Okay, this is some factor related to motion itself. It can be damping coefficient, it can be forced oscillation. So obviously its presence will not affect the main functionality of the oscillatory motion. So here from this we can comfortably say that here amplitude is a only. Okay, so hence I'll write option A as my right choice here. Now fifth question. Two simple harmonic motions are represented by the equations y1 is equal to zero point 0.1 sine of 100 pi t plus pi by 3 and y2 is equal to 0.1 cos pi t. The phase difference of the velocity of the particle 1 with respect to the velocity of the particle 2 is. Okay. Now in this particular question, I'll write back the equations first. Y1 is equal to zero point 0.1 sine of 100 pi t plus pi by 3. Second equation is zero point 0.1 y2 is equal to zero point 0.1 cos pi t. Now these are two equations that have been given to us. Then I'll differentiate first equation with respect to time. Then I'll get this as what? V1, is it not? So this is V1 here. So hence V1 is equal to dy1 by dt, that will be 0 0.1 into 100 pi cos of 100 pi t plus pi by 3. Okay, so that is value of velocity v1. Now similarly, I'll find velocity v2 here. Velocity v2 is derivative of y2 with respect to time. So here I'll get this as minus zero point 0.1 pi sine pi t. Okay. Now this particular equation, I'll write it in the form of allied angles method. Okay. So I'll write it as 0 0.1 pi cos of pi t plus pi by 2, because cos of pi by 2 plus theta is minus sine theta, so I am writing reverse here. Remember that. Okay, so hence I am mentioning it like this. So accordingly, if you just observe here, the phase differences are quite simply understandable. Phase difference of velocity of first particle with respect to second particle, if you just observe at t is equal to 0, okay, then I can write it as delta phi is equal to phi 1 minus phi 2. Now phi 1 is pi by 3, is it not? This is pi by 3 here. Then phi 2 is pi by 2, right? So pi by 3 minus pi by 2, that should give me minus pi by 6. So that is the final answer that I can quote here. Okay. Now let us move on to question number 6 now. In question number 6, the periodic time of a body executing simple harmonic motion is 3 seconds. After how much interval from time t is equal to 0, its displacement will be half of its amplitude, they are asking. Okay. Now in this particular question, y is equal to a sine of 2 pi by capital T into small t. I'll mention this because in the problem here they have given time period. It is 3 seconds, right? So hence I'm writing the simple harmonic motion equation like this. Hopefully you can make this out. Then here y is equal to a by 2 they have given. So hence I can write a by 2 is equal to a sine of 2 pi t by 3, right? Because capital T is 3 here. Can cancel a, then we can see that we'll get this as sine 2 pi t by 3 is equal to 1 by 2, or 2 pi t by 3 is equal to pi by 6, is it not? 30 degree. So hence I can write this as 2 pi t is by 3 is equal to pi by 6, therefore t is equal to 1 by 4 second. So that is the answer, right? So we have found the answer to this question, dear students, is it not? Now let me move on to seventh question. A body is executing simple harmonic motion when its displacement from the mean position is 4 centimeter and 5 centimeter. The corresponding velocity of the body is 10 centimeter per second and 8 centimeter per second. So when displacement from the mean position is 4 centimeter, velocity is 10 centimeter per second. When displacement from the mean position is 5 centimeter, the velocity of the body is 8 centimeter per second. So now using this relative condition, find the time period of the body. They're asking us to find the time period of the body here. So accordingly, I'll mention velocity equation as omega into square root of a square minus y square. Okay. Then we have initially v is 10, right? So at y is equal to 4, v is equal to 10. So hence I'm mentioning it like this. Fine. Then second case, at y is equal to 5, v is 8, so hence I am writing it as equation 2 now, like this. Okay, now after this, now let us go ahead and solve these two equations. If you just simplify these two equations, okay, I will get the value of omega as 2 radian per second. Then accordingly, omega can be written as 2 pi by capital T, right? That is equal to T. So therefore time period T will be equal to what? Pi second here. That's it. Okay, so we have found the answer to this question. Pi second is the required time period. Now let us move on to eighth question now quickly. Dear students, we are getting accelerated here. So definitely this is a plus factor for us because we are solving the problems at a very quick succession. So the amplitude of a particle executing simple harmonic motion with frequency of 60 Hz is 0.01 meter. The maximum value of the acceleration of the particle is. So they are asking us to calculate maximum value of acceleration of the particle. They have given frequency, okay, they have given amplitude, okay. Now based on this we can find the maximum acceleration. So I you would have got the hint here. Now frequency is 60 hertz, no? So hence I can very easily relate it to omega. So hence maximum acceleration can be written as a omega square, okay, that is equal to a into. Now omega can be written as what? 2 pi f, right? So 2 pi f whole square. Omega is 2 pi f. Now hence its whole square is 4 pi square f square, right? So thus I can mention straight away the answer as 144 pi square meter per second. Hi Soham. Okay, Soham, you are writing KCET 2022, right? Okay, so I suggest you start your preparation from what chapters you have covered already in theory part. Okay, so just focus on them and try and solve the objective questions. First and foremost thing, you just try and do that. Okay, and suppose if your target is Karnataka CET, then prepare Karnataka CET by taking good help from your NCRT textbook as well as exemplar book. Then you just go with a dedicated uh, education sessions on Unacademy. Now these are three things I would suggest. Okay, very good evening, VT Patel. So, in fact, with this note, dear students, I have come to an end today with my discussions on problems on previous year questions. And again, day after tomorrow, I'll come with second part of this particular discussion. Okay, so I will meet you back on day after tomorrow at 6:30 p.m. Yeah. Oh, you are targeting JW, right? Okay. That's great. That's great, Soham. No problem. For JW preparation as well, I suggest you start preparing with exemplar problems from NCRT exemplars. RV College. Okay. For getting RV College, definitely you should get a ranking of around within say about 500 in order to get computer science kind of branch. Okay. VT Patil, you are writing JE in March 2021. Okay. Fine, that's well and good. I wish you all the great success for your preparation. But Patil, you focus more on preparing with your NCRT exemplar first and foremost thing. Please do that. Ah, you have state quota, right? Okay. Don't worry, Soham. I will be coming up with a particular session on this part on YouTube. I'll help you out. Okay, rural and Article 371 you have, right? Okay, no problem. But still, you may have to go through Karnataka CET segment that Horanadu Kannadiga, outside Kannadiga segment. Okay, you can apply. Okay. Some tricks about physics. Okay. Miss Patil, can you please attend my session day after tomorrow? I will be able to help you out at that time. Definitely, I'll help you out because today my time is up. So my session is usually in between 6:30 to 7. So I will meet you back day after tomorrow. Okay. So please do attend my session on day after tomorrow. I'll help you out. Don't worry. I'll help you out. I'm here to help you out. Okay. Thank you very much. Have a wonderful time. I will see you back in my next session. Take care. Bye bye.